देखिए इस क्वेश्चन में क्या एक ऑब्जेक्ट है जिसकी स्पेसिफिक ग्रेविटी रो है, इसे हम हंग कर रहे हैं एक थिन स्टील वायर से। तो फंडामेंटल फ्रीक्वेंसी हमारी जो ट्रांसफर स्टैंडिंग वेव फॉर्म हो रही है वायर के अंदर उसकी है 300 हर्ट्ज। अब हम क्या कर रहे हैं, अब हम ऑब्जेक्ट को वाटर में इमर्स कर रहे हैं सच दैट हाफ ऑफ द वॉल्यूम जो हो वो सबमर्ज हो जाए। तो न्यू फंडामेंटल फ्रीक्वेंसी हर्ट्ज में हमें निकालनी है। तो देखो फर्स्ट केस तो ये हो गया हमारा ऐसा कि ये थी एक वायर स्टील की और इससे हमने क्या किया, एक ऑब्जेक्ट को हंग कर दिया, ठीक है, एयर में। तो इस केस में देखो ये अगर बात करें हम बॉक्स की तो क्या होगा, देखो हमारा जो टेंशन टी होगी स्ट्रिंग में वो किसके इक्वल होगी, ये हमारा फर्स्ट केस है, ठीक है। केस 1 के लिए हम बोल सकते हैं कि जो हमारी टेंशन टी होगी वो किसके इक्वल होगी, वो मास एम जी के इक्वल होगी। सपोज ये मास एम है, एम जी, और ये टेंशन टी है, ठीक है। तो टेंशन एम टी माइनस एम जी 0 होगा बैलेंस कंडीशन में, तो टेंशन क्या आ जाएगी, टेंशन एम जी आ जाएगी। अब मास को मैं कैसे लिख सकती हूँ, मास को मैं लिख सकती हूँ रो दे रखी है जो स्पेसिफिक ग्रेविटी इंटू वॉल्यूम वी इंटू जी, रो वी जी लिख सकती हूँ। ये मेरा फर्स्ट केस हो गया, ठीक है। अब फर्स्ट केस की फ्रीक्वेंसी निकाल लेते हैं। फ्रीक्वेंसी का फॉर्मूला क्या होता है, 1/12 टाइम्स ऑफ अंडर रूट टी बाय मास, ठीक है। तो यहाँ पे क्या होगी हमारी फ्रीक्वेंसी एफ होगी कितनी, 1 लेंथ ऑफ वायर 12 अंडर रूट टेंशन क्या है रो वी जी अपॉन मास एम, ये आ गई, ठीक है। अब सेकंड केस पे चलते हैं। सेकंड केस में हम क्या कर रहे हैं, फिगर बनाती हूँ। ऐसी कोई वेसल है जिसमें हमने इस अपने ऑब्जेक्ट को हाफ इमर्ज कर दिया, मतलब v/2 वॉल्यूम जो है वो वाटर के अंदर है, v/2 एयर के अंदर है, ठीक है। अब इस केस में देखिए क्या होगा, इसमें कौन कौन से फोर्सेस लगेंगे, एक तो mg लगेगा नीचे को, टेंशन t है हमारी, ठीक है, और क्या है, और है हमारे पास अप थ्रस्ट। अप थ्रस्ट भी ऊपर लगता है बॉइंट फोर्स, ठीक है। तो इससे क्या आ जाएगा हमारा, हमारे पास टेंशन टी क्या आ जाएगी, आ जाएगी mg माइनस अपथ्रस्ट फोर्स। बैलेंस कंडीशन में t प्लस अपथ्रस्ट फोर्स mg के इक्वल होगा, तो टेंशन क्या आ जाएगी mg माइनस अपथ्रस्ट फोर्स। तो उसमें मैं mg को क्या लिख सकती हूँ, रो वी जी, और अपथ्रस्ट फोर्स क्या होता है, ये होता है कि रो ऑफ, किसका रो लेंगे इसमें, रो ऑफ वाटर, और वॉल्यूम ऑफ लिक्विड डिस्प्लेस्ड क्या है, v/2 है इंटू जी, ये होता है। तो ये आ जाएगा यहाँ से, अगर मैं vg/2 बाहर लूँ तो ये क्या आएगा, 2 रो माइनस रो ऑफ वाटर, ये आ गई मेरी टेंशन। अब इससे मैं फ्रीक्वेंसी निकाल लेती हूँ फॉर्मूले में रख के, एफ डैश। इस केस में सेकंड केस में मेरी फ्रीक्वेंसी होगी 1/12 अंडर रूट में क्या, vg/2 2 रो माइनस रो डब्ल्यू अपॉन एम, या मैं 2m लिख सकती हूँ। तो इसको मैं इस फॉर्म में लिख सकती हूँ कि यहाँ से मैं अंडर रूट ऑफ वी जी रो बाय एम ऐसे ले लूँ, तो यहाँ क्या बचेगा, यहाँ बचेगा 2 रो माइनस रो डब्ल्यू अपॉन रो, अपॉन क्या आएगा, vg/2 था ना, अपॉन 2 रो, ये आ जाएगा। तो ये क्या होता है, ये पूरा टर्म मेरा 1/12 रो वी जी बाय एम एफ था, तो ये आ गया एफ टाइम्स ऑफ अंडर रूट 2 रो माइनस रो ऑफ वाटर डिवाइडेड बाय 2 रो, ठीक है। ये आ गया मेरा एफ डैश। तो एफ की वैल्यू क्या गिवन है, एफ की वैल्यू गिवन है 300 टाइम्स ऑफ, क्या लिख सकती हूँ मैं इसे, 2 रो माइनस रो ऑफ वाटर क्या होता है, 1 होता है, अपॉन 2 रो, स्पेसिफिक ग्रेविटी ऑफ वाटर होती है मेरी 1, रो ऑफ डब्ल्यू मैं लिख सकती हूँ 1, ठीक है। तो ये मेरा एफ डैश आ गया। ये कौन सा ऑप्शन है ये अभी हम देख लेते हैं। ये है हमारा 300, ये है हमारा फर्स्ट ऑप्शन। ठीक है, फर्स्ट ऑप्शन में यही बात बोली है, तो हमारा फर्स्ट ऑप्शन क्या है, सही हो गया और बाकी सारे रॉन्ग। ए ऑप्शन इज करेक्ट। ठीक है, तो ये क्वेश्चन सॉल्व हो गया हमारा।
Hello everyone, let's start our section. The question says a wave represented by the equation y equals a cos kx minus omega t is superimposed with another wave to form a stationary wave such that the point x equals 0 is a node. The equation for the another wave. Okay, in this question we are provided with a wave which has equation y equals a cos kx minus omega t, and it is superimposed with another wave. It is superimposed with another wave to form a stationary wave. The two wave form stationary wave. And it is also given that the point x equal to 0, it is node. A node that formed in a stationary wave is at the point x equal to 0. And we have to find equation for the another wave. So a stationary wave or a standing wave means when a two wave of same frequency and amplitude travels in opposite direction. That is a stationary wave. Same frequency and amplitude. Same frequency and amplitude. Stationary waves are waves which have same frequency and amplitude. Travels in opposite direction. Opposite direction. This is a definition for a stationary wave. And a node is a place in a wave where the amplitude is 0. Amplitude is defined as 0. Node is a place where amplitude is 0. Amplitude is 0. So first of all, let us assume that y2 be the second wave. Let's assume that y2 be the second wave, that is y2 equals plus or minus a cos kx plus omega t, and let y1 be the given wave, that is y1 equals a cos kx minus omega t. In the first case, we are going to assume that the second wave, the another wave is positive, that is the y2 which is given as plus or minus a cos kx plus omega t is positive, that is a cos kx plus omega t, and our given wave y1 is a cos kx minus omega t. We are going to add both these wave, that is y resultant are equals y1 plus y2, that equals a cos kx minus omega t plus a cos kx minus omega t. This equation is in the form of a trigonometric equation, that is a cos x plus y plus a cos x minus y, and their resultant is given as 2a cos x plus cos x cos y, cos x cos y, cos y. And if we consider in this equation, we will get the resultant yr as 2a cos kx cos omega t. We have said that a node is a place where the amplitude is 0. So the given node is at the point x equals 0. That is, when the x equals 0, there is no amplitude. The amplitude is 0. which means the y coordinate should be equal to 0. So when x equal to 0 in the first case, that is yr becomes 2a cos k into 0 cos omega t, and y resultant will be 2a, and cos 0 will be 1. We will get the y resultant 2a cos omega t, which is not equal to 0. So we'll move on to the next part, that is we will consider y2 has minus of a cos kx plus omega t. This will be our another wave, and our given equation y1 equals a cos kx minus omega t. Their resultant will be y1 plus y2, that is y resultant, and it will become a cos kx minus omega t minus a cos kx plus omega t, and this is also in the form of a trigonometric equation, and their resultant yr will become 2a sin kx into cos omega t. Now we are going to substitute for x equals 0. At x equals 0, y resultant will be 2a sin k into 0 into cos omega t. So yr equal to 2a sin 0 into cos omega t, and the y resultant will be 2. So 2a into sin 0 is 0 into cos omega t. So the y resultant will be equal to 0. That is, so we have said that a node is a place where the amplitude of a wave is 0. That means both x and y are 0. We have find that y2, which represented by minus of a cos kx plus omega t, which is equal to 0. So our resultant wave or the another wave is represented as option C, minus of a cos kx plus omega t. Okay, thank you.
Hello everyone. Let's begin with the question. And in the question, it says that a cylindrical tube open at both ends has a fundamental frequency F, and the tube is dipped vertically in water so that half of its length in water. So fundamental frequency of the air column is now. Okay, so we have to discuss both the cases here. Let's say that uh, let's draw the diagram to understand the things clearly. Let's say this is the initial case, and here it is. And in this case, here everything is forming in the air. So this is the initial case, and after that, let's say there is, and here we will what we do here, we will pour some amount of water into it. So let's see here. So till here, the water inside it. Now initially it says that the tube has a fundamental. Initially it says that a cylindrical tube open at both ends has fundamental frequency f in here. So in that case, for fundamental frequency, if it travels like this, then it will be the case 1. And if we assume that this length is L, okay, so here, as we know, this is antinode and this is also antinode, and distance between the two antinode is lambda by 2. Okay, and since the distance between the antinode here is equal to L. So that means lambda by 2 will be equal to L. And from here we get lambda is equal to 2L. Now one more thing, frequency is equal to velocity by lambda. So from here frequency will come out as V by 2L. So this is the equation number 1, and this is the frequency that we have obtained here by using this. And here there is no water. Now after some time there is water here. So in that case the scenario will be like this: rest is covered here is by water, and only this, because it says in the question that the tube is dipped in water, so that half of its length in water. So here half of its length in water and half is forming a node and an antinode. So half length, that means this length will be L by 2, and the distance between a node and an antinode is lambda by 4. So we can say that L by 2 here is equal to lambda by 4. With that we can say that it's, let's say it is lambda dash, so lambda dash will be equal to 2L. Now again by the formula of frequency is equal to, it is f dash into V by lambda dash, and finally frequency f dash will come out here as V by 2L, and this is equal to frequency of the case when it was in air. Here it is in water and here it is in air. So with both these values, or say this is equation 2, so from equation 1 and equation 2 we can say that the frequency is not going to change. Fundamental frequency in both cases will be same. So with that the answer C, or the option C, is the right answer, that the fundamental frequency is same in both cases. So this was about this question. Thank you for watching.
Hello students, today our question is, in an experiment to measure the speed of sound by resonating air column, a turning fork 500 Hz is used, and the length of the air column is varied by changing the level of water in resonance tube, and the two successive resonances are heard at column length 50.7 and 83.9. Which of the following statement is true? ABCD statement is given about them. So the solution of this question is, we have, let N1 be the harmonic corresponding to, let N1 is harmonic corresponding to 50.7 centimeter, and N2 be harmonic to 83.9 centimeter here. So both are consecutive harmonics, so their differences, both are consecutive. So their differences lambda by 2, that is wavelength divided by 2. So from this we can write here wavelength divided by 2 is 83.9 minus 50.7 here. So from this we get wavelength is 33.2 into 2 here. So from this we can say that lambda is equals to 66.4 centimeter here. So this is the wavelength here. This is wavelength, and wavelength divided by 4. This is 16.6 centimeter, and the length of the corresponding mode must be close to lambda by 4, and 50.7 must be close to odd multiple of length 16.6 into 3 here. So therefore 50.7, from this we can say that third harmonic is 50.7 here. So E plus 50.7 is equals to 3 lambda divided by 4. So from this we can say that E is equals to 49.8, and this is minus 50.7. So this is 0.9 centimeter here, and the speed of sound is this will equals to V is equals to frequency divided by wavelength. So V is equals to 500. V is equals to, we know that velocity is frequency multiplied by wavelength. So this is F into wavelength, that is lambda. So frequency is 500 and lambda is 66.4 here. So this is 332 meter per second here. So this is the velocity. So from this we get the velocity is this, E is this, and we have the this. So now we check which options are correct here. The speed of the sound determined this from this experiment is 332. So this is correct here. The end correction in this experiment is 0.9 centimeter. This is also true here. And wavelength is 16.65 here, and the resonance is corresponding to, this is incorrect here. So A, B, C are correct. Thank you.